Oftentimes, the biggest levers that we have in operations management are in the design phase. It is in the design phase where a large majority of the production costs of a new product are actually determined. So far in this module we have primarily focused on designing a clever process to deal with the effects of variety. In this session we'll think about how a clever product design can reduce the negative effects that variety has on process performance. We'll introduce the concepts of modularity, platforms, and delayed differentiation. An automotive assembly line is a fascinating place to visit. Join me in a walk through a plant. As we go from the beginning of the line to the end of the line, where the cars are going through a last round of quality inspection before they are made ready for shipment, I want you to pay careful attention to the amount of variety that you will see in the process. Here, in the upstream at the beginning of the line, there exists relatively little variety. All these bodies of cars still look very much the same. There's no paint on it, there's no dashboard, no electronics, no color, nothing. Variety increases once we go through the coloring of the vehicle. Once the paint job is done, cars come out with multiple colors. Then there are engines that are installed. Some of them have big engines, some of the cars have small engines. Further along, we'll introduce audio systems and other electronics, different interiors, and towards the end of the process, we have a very large amount of variety. So, as we observed, the variety increases as the journey through the production process unfolded. This is not just specific to the car. We could have made the same observation in a Subway restaurant. At the beginning of the process, I just have 2 or 3 different types of bread. At the end of the line, at the cashier, I have hundreds and hundreds of different potential flavors, recipes, and options that customers have chosen. Now let me offer you the choice between 2 different process designs. In both cases, we start with a limited amount of variety, and then at the end of the process, in both cases, we provide the same options. For example, different colors of our flow unit. However, in the first processor layout, the way the process unfolds is that the process is common across all flow units, across all colors till the very end, and only at the end will I configure the product into the many different product variants. In the second option, in contrast, I make the decision at the upfront. Right at the first step, I'll add the color to the process, and I'll then separate the process flows for each of the different variants. Which of the 2 processes would you prefer? Most of us would intuitively prefer the first option. We see a form of scale economies in the process because here, look at the first step following the kind of process beginning here. Everything I'm producing is standardized to one variant, whereas here it is spread over multiple different units of demand. In other words, here I'm suffering from this problem of demand fragmentation that we discussed in an earlier session. Or put differently, I'm benefiting from the effect of pooling here at this first resource. Pooling is a form of scale economies, and the variability thus that we're going to experience here at this resource will be lower compared to the variability that we're going to encounter at each of these individual process steps. The strategy of the first option that we just discussed is often referred to as delayed differentiation. Delayed differentiation means simply that we delay, or often called, we speak of postpone, we delay or postpone the decision of which product variant a particular flow unit will end up to until the very last moment in the process. The classic textbook example of delayed differentiation comes from the apparel industry. Benetton is a company that sells t-shirts, polo shirts in many different colors. What color is hot at what moment of time is really hard to predict, and so Benetton faces a lot of demand uncertainty. Now imagine two production processes. In the first production process, we take the different colors apparel and we send them through the production process of making a shirt. The alternative, and that's a great insight that Benetton came up with, is we're producing one generic shirt color all through the process until the very end, and it's only at the last step that we're going to put the color in. Again, this is the idea of delayed differentiation. Let me give you an additional example. Last year, my wife and I decided to buy a Toyota Prius. We decided about the color of the car, we decided about the navigation system and the electronics, and we decided what type of seats we wanted in the car. Those are the options that Toyota offers to you. Unfortunately, our local dealer didn't have the combination of car color, seat color, and navigation system that we wanted. To our great delight, however, within a day they could take another car that they had on the lot that had the same exterior color, and they could adjust the navigation system and they could swap out the seats. So while they're not like Benetton, they could not change the exterior color, they couldn't just put the car into a bath of paint and make a gray car into a blue car on the last day, they were able to change the navigation system and the leather seats on site at the dealer. That allowed them to postpone the decision of what exact Prius variant they were selling until all the way into the dealership. This in turn allows them to benefit from some of the demand pooling. What allowed my Toyota dealer to delay the differentiation between a car with GPS and a car without GPS, as well as a Prius with leather seats and a Prius without leather seat, was that the components were modular. A Prius with or without navigation system was exactly the same platform except for one part, namely the navigation system. This is shown in this chart here. Look how on the left we have a product that consists of 4 components, but each of the 4 components is colored. So the first unit here appears as green, the next one is light blue, dark blue, and so on. Compare this with the product design on the right. Here I have a common platform across all the colors that I'm offering, and I've isolated the color into one specific part. Isolating the color in one part refers to a modular product design. That casing around my product does nothing than creating the appearance of color. I've isolated the function colored to one specific component. This is the definition of modularity. A nice example these days is the iPhone. You notice how this design over here is exactly like the iPhone design with a case. People like to personalize the iPhone, but it's not happening in Apple's production, but it is happening in the form of the screensaver as well as in the form of the case that people put around their phone. At the beginning of this module, I shared with you my experience of buying an HP printer at Amazon. Recently, the box finally arrived and I was eager to look inside. It was interesting how the box was organized. You notice how the power supply in the box was kept separate from the printer. This allowed the folks at HP to wait till the very last moment with a decision whether this box should be shipped to the US, the European market, or to Asia. Since the power supply varies across these regions, this was really the only thing that was unique to the American printer. I also noticed that this printer shared many components with another printer that I already had in the office. Through clever product design, firms are able to share products and processes across things that they offer to the customer, yet to the customer offer a high degree of choice.